Hi everyone. In this video we are going to discuss how to solve such problems, such differential equations. Actually it is of reducible to exact differential equation type. So let us see how to solve such problems. Before starting this example, we will revise few things related to exact differential equation. Okay, and then we will solve this problem. Actually in previous videos we have already covered, but let us recall this concept and then we will move further. So when you have differential equation of this type, m dx plus n dy is equal to 0. When you have this kind of differential equation, we call it as exact if delta m by delta y is equal to delta n by delta x. That means if these two partial derivatives are equal, then we say the given differential equation is exact. Here m and n, these are functions of x and y. So you can easily compare this format with a given differential equation. Multiple of dx, that is our m, multiple of dy, that is our n. So let me write our m and n first, right? Here m, which is multiple of dx, 3x square y raised to 4 plus 2xy, n, which is multiple of dy, 2x cube y cube minus x square, right? So this is our m and n. So when we can say it is exact differential equation, if these two partial derivatives are same, first of all we will check whether it is exact or not. If it is exact, it is quite simple to solve, but if it is non-exact, we need to convert it into exact differential equation. Okay, so let us start to check. Let us find partial derivative of m with respect to y, right? Partial derivative of m with respect to y. So you can see there are two terms, right? And these are separated by addition. So what will I do? I will take separate derivatives. Derivative of first term 3x square y raised to 4 plus derivative of second term 2xy. Now what will I do? If there are any constants, I will take them outside. So here we are differentiating with respect to y. So x square is constant since we differentiating with respect to y. So you can take it outside since it is constant. 3 is also constant. So 3x square will come outside. Inside the derivative we have y raised to 4. Let us talk about the second term. Here we are differentiating with respect to y. So x is constant, 2 is also constant, they will come outside. So we have derivative of y only, 3x square. So let us see how to find derivative of y raised to 4. So in such cases, we use this formula. The derivative of x raised to n is n x raised to n minus 1. This is very simple formula. Very frequently we use this formula, right? So this formula says when you have any power, we write that power here and we reduce the power by 1. So here the power is 4. So I will write 4 before that y. I will reduce it by 1. So you will have 4y cube, 2x. Derivative of y with respect to y. So this is very basic and simple formula. That is derivative of x with respect to x is always 1. So derivative of y with respect to y 1. So into 1 you can write, but when you multiply by 1 you will get same. 3 into 4 12 x square y cube plus 2x into 1 2x. That's it. So we got the first partial derivative. Let us move further. Let us find d by n by d by x now, second partial derivative. So now derivative of n with respect to x. See, in n we have two terms which are separated by minus sign. So when you have addition or subtraction of two terms, we can take separate derivatives. Let us take separate derivatives. Derivative of 2x cube y cube, right, minus derivative of x square. I will repeat the same thing. What I will do, I will take the constants outside. We are differentiating with respect to x, so y cube is constant, 2 is a number, so obviously it is a constant. Both of them will come outside. Inside we will have simply x cube. Here nothing is constant, x square is there, it's a function of x and we are differentiating with respect to x, so we supposed to find its derivative. So we have this formula to find derivative. Okay, same formula I will use it here again. Simply at a place of n we have 2. That formula says whatever the power, we write it here. We reduce the power by 1. So 2x raised to 1, that means 2x. So this is 2y cube. I will use the same formula, x cube. So 3x square minus 2x. Okay. So where shall I write? Let us use this space to solve the remaining part of this problem. This is equal to, okay, this is equal to 2 into 3, 6 x square, right? X square, and y cube is also there. I supposed to write y cube, and here minus 2x. Okay, so now let us see these two derivatives are same or not. This was the first partial derivative we found out, and that is the second partial derivatives. So a lot of difference is there. Here plus 2x, there is minus 2x, here 6, we have 12 getting. So obviously these two partial derivatives are not same, these are unequal. So this is the differential equation is non-exact. So let me clearly mention. So therefore delta m by delta y is not equal to delta n by delta x. It means given differential equation is non-exact. Getting? So if it is non-exact, now then we have to convert this given differential equation into exact differential equation. Now the question is, how can we convert? So with the help of integrating factor. Okay, so that means we supposed to find the integrating factor first. We will multiply given differential equation by integrating factor, then it will be converted into exact differential equation. Now the question is, how shall we find integrating factor? See, there are 4 different ways. There are 4 different rules of finding integrating factor. Okay, so we will check whether which rule is applicable, and if any rule is applicable, we will use that rule to find integrating factor. The first rule is delta m by delta y minus delta n by delta x upon n. This is function of x only. Okay, so what we do, we take the difference, we subtract the second partial derivative from the first one, we divide that term by n. If we get the function of x, in that case integrating factor is e raised to integration f of x dx. In power of e we solve that integration. Getting? Here we should have just function of x only, there should not be any y, then only the first rule will be applicable, right? Let us talk about the second rule. The second rule is delta n by delta x minus delta m by delta y upon m. Simply I change the role of m and n here. Okay, just very small difference. It should be the function of y only, then integrating factor will be e raised to integration f of y dy. So here also that term should be a function of y only, there should not be any x. See, we cannot check it directly, we need to solve, then only we will realize yes it is function of x or it is function of y. Okay, so without solving it is not possible to identify which rule is applicable from 1 and 2. Let us go for rule number 3. So rule number 3 says the function should be in this format: y f1 of xy dx plus x f2 of xy dy is equal to 0. Getting? So I have not written comma there. It doesn't mean that it is a function of x and y. It's a function of xy. Getting? So that means everywhere we should have xy, x square, y square, sin xy, log xy. Everywhere we should have simply xy. Then only the rule number 3 is applicable. Actually, I have not written the complete rule here. Simply I mentioned the condition. If this condition is satisfied, then only the rule 3 is applicable. The last is function differential equation should be homogeneous. Homogeneous, that means power of each term must be same. Okay, so generally what I suggest, okay, this is also a condition again, huh? If this condition is satisfied, then only we will go for rule number 4. But see, generally I suggest you can check rule number 3 and 4 first, because it's quite simple to check whether rule number 3 or 4 is applicable or not. So when you solve any problem in exam, getting, it is not mentioned, it will not be mentioned that use this rule to find integrating factor. In that case, you need to decide which rule is applicable. So I always suggest go for rule number 3 and 4 first, because you can easily check. whether they are applicable or not. If they are not applicable, then only go for rule number 1 and 2 and you can check which one will be applicable. Homogeneous, power same. Here the combined power is 6, you can say 2 plus 4, 6. Here the combined power is 2, here the combined power is 6, here the combined power is 2. So each term does not have the same power. 2, 2, 2, 2, every term should have, or 6, 6, 6, 6. Here we are having 6, 2, 6, 2. So that's why the fourth rule is not applicable, the condition is not satisfied, it is not homogeneous. Let us go for the further, yes, third rule. xy, xy, xy should be everywhere, getting? So here we have xy, but here x square y raised to 4. Here we should have the same power, x square, then we should have y square, or if you have y raised to 4, then you should have x raised to 4. So that's why again the third rule is also not applicable. Here also we have just x square, there is no any y. So the rule number 3 is also not applicable. So last two options we have, that is either we should go for rule number 1 or 2. But right now I cannot say which rule is applicable. I also need to solve it, getting? So what will I do? I will solve in rough. I will check whether rule number 1 is applicable or not. If it is applicable, we will go with it. Otherwise, last option, rule number 2. So let us simplify. Okay, I am doing it in rough. Deba m by deba y minus deba n by deba x upon n. Okay, let us find deba m by deba y. Where is it? My deba m by deba y? Here. 2 x square y cube plus 2x minus deba n by deba x. I need to subtract this one. Minus 6x square y cube minus minus plus 2x upon n. Where is my n? 2x square y cube minus x square. Okay, let me remove this part, or I will continue here, the remaining part here. So 12x square y cube minus 6x square y square y cube, that means 6x square y cube. 2x plus 2x, 4x. In denominator you can take x square common, so 2y cube minus 1. Okay, simply I am checking that what can I take common? X common, you can take 6xy square plus 4 upon x square 2y cube minus 1. So 1x will get cancelled, but still all remaining terms will be there involving x and y both. What we expect here, we should have just function of x only, and we are not getting function of x only. Y is also there and we cannot remove it. That's a problem. So that's why rule number 1 is not applicable, getting? So first rule not applicable, third and fourth are also not applicable. So we have just last option, so rule number 2. Okay, so I'm damn sure it will be applicable since all remaining rules are not working. So let me remove this part. I will go with rule number 2. Okay, see, actually in exam also you should follow the same method to check which rule is applicable, right? So let us go for rule number 2. So consider, so you are familiar with rule number 2. Let me mention here, deba n by deba x minus deba m by deba y upon m. Let us check what is deba n by deba x. This one, 6x square y cube minus 2x minus deba m by deba y. Where is it? This one, 12x square y cube, 12x square y cube. See, there is minus sign outside, na? So that's why I'm changing this sign, minus 2x. And what is my m? This is 3x square y raised to 4 plus 2xy. So 6x square y cube minus 12x square y cube, it will be minus 6x square y cube minus 2x minus 2x minus 4x. Here what can I take common? I can take xy common here, getting? So 3xy cube is remaining here and 2 is remaining there, getting? So tell me, from numerator what can I take common? From numerator I can take minus sign common, from numerator I can take x common, from numerator I can take 2 common. So minus common, 2 common, x common. So what is remaining? Yes, 3 will be there, 1x went outside, so x will be there, xy cube, that's it. Minus sign we took common, out of 4, 2 we took common, x also we took common, so that's why we'll have just 2 only, upon xy, 3xy cube plus 2. So you can easily see we have got a same bracket at numerator denominator, so we can cancel it. And I feel really so much happy if I get if I can cancel something, okay, that means we are on the right track. So here also x will get cancelled, and finally we will have minus 2 by y. So it's a function of y only, there is no any x. That means we are right, the condition is satisfied, we are getting function of y only. So tell me what will be the integrating factor. Our formula says integrating factor is e raised to integration f of y dy. That means in power of e we are solving an integration. Let us do e raised to minus, what is my f of y, f of y minus 2 by y dy, e raised to, so minus 2 is constant, we can take it outside, minus 2 came outside, 1 by y dy. Do you know integration of 1 by y? It's very simple, it is log y. So e raised to minus 2 log y. Actually log and e always get cancelled to each other, but the problem is that we have a minus 2 between them, so you cannot cancel directly. So what I'm going to do, I'm going to use one property of log, that is n log a is equal to log a raised to n. So that means when you have any number as a multiple of log, you can shift that number to the power of a. So the same thing is happening here, minus 2 can go to the power of y. So we'll have e raised to log y raised to minus 2. So now that barrier is removed and e and log are open. Okay, so you can cancel them and you will get y raised to minus 2. Power is negative, that means you can shift to the denominator. So you will get 1 upon y square. So this is required integrating factor. It means if you multiply given differential equation by this 1 upon y square, it will be converted into exact differential equation. Okay, so let me call it as 1. Okay, and I will say multiplying equation 1 by y square. Okay, so there is no more space to write, just make a screenshot of it, then we will move further. So I have multiply equation 1 by y square, right? So how many terms are there? Total 3 terms, first term, second term, third term. Third term is 0. So I'm multiplying each term by 1 by y square, but see that y square is in denominator, so everywhere it will appear in denominator. So the equation will look like this: 3 x square y raised to 4 plus 2xy upon y square dx, 2x cube y cube minus x square upon y raised to 4 dy, and 0 upon anything 0, right? After that, what will I do? I will divide separately, so that's why we can cancel few terms there. So let us divide separately. 3 x square y raised to 4 upon y square plus 2xy upon y square dx. Here also I will do the same. 2 x cube y cube upon y raised to 4, minus sign is there, my mistake, minus x square upon y raised to 4 dy is equal to 0. So we can cancel y square will get cancelled. 3 x square y square. Here 1 y will get cancelled, 2x by y dx, plus here y cube will get cancelled, 2x cube by y. Here nothing we can cancel, x square by y raised to 4 dy is equal to 0. So finally we multiplied the given differential equation by integrating factor. So now it is converted into exact differential equation. Let me clearly mention, this is an exact differential equation. So this is our new m, this is our new m, n. Let me mention, our m is 3x square y square plus 2x upon y, and n 2x cube by y minus x square by y raised to 4. Okay, see this is exact differential equation. In previous video we have already seen how to solve exact differential equation, but let us recall those things in short. So when you have exact differential equation, the solution is integration m dx by treating y constant, and we are taking n here, terms of n which are free from x, dy is equal to c. That means the solution of exact differential equation is simply the sum of two integrations. The first integration of m, where we treat y constant, and the second integration we consider the terms of n which are free from x. Dy is equal to c. So let us solve these two integrations. Let us focus on first integration. So let me continue here. So now integration m treating y constant, right, dx. What is my m? My m is this one. So 3 x square y square plus 2x by y dx. So you know, if there is addition we take the separate integration, and constants also I will take outside. Here the y square is constant, since we have already mentioned y is constant. 3 is also constant, so 3y square will come outside, inside the integration x square only. Addition is there, I am taking separate integration as well as constants outside. Here 2 by y is constant, so we have simply x dx. Okay, so now the question is how to solve the integration. So we have very simple formula, that is integration of x raised to n is x raised to n plus 1 upon n plus 1. Very simple formula. Getting? So what is n here? N is 2, you can see. So the formula says whatever the power, increase it by 1 and the same number in denominator. So 3y square. So will you tell me what will be the integration? Increase the power by 1, so x cube, same number in denominator. That's it, finish. Plus, let us use the same formula here. What is the power of x? Nothing is there, that means 1 is there. Increase it by 1, so it will be x square, same number in denominator. So you will get benefit of it, that is 3 will get cancelled here, 2 will get cancelled. So what will be the final answer? So it will be x cube into y square and x square by y. Generally what I do, I always write x first and y second. Doesn't matter, if you write y square x cube, that is also correct, no issue. So in this way we got the value of first integration. Let us go for the second integration. So now second integration, it contains terms in n. Okay, so let me write properly. Terms in n free from x, integration with respect to y. So let us see how many terms are there in n. You can easily see there are two terms, first term, second term. Terms in n free from x, that means there should not be any x. Is there any x in first term? Yes, x cube is there, so you cannot take the first term. Is there any x? Yes, so you cannot take the second term. That means n had only two terms, both of them are having x, so you cannot take any term of n. So the value of integration is 0. So let us write the final solution. The solution is nothing but sum of these two integrations. Okay, so value of first integration I got x cube y square and plus x square by y, and the value of second integration is 0. We are adding 0 here, so you will get the same term, and is equal to c. That will be the final answer. So in this way we solved this problem completely and we got the final answer. Okay, so just make a screenshot of it. After that I am going to give you one practice problem. So right now we will stop here. The next problem we will discuss in next video. Thank you. See you in next video.